Class will be recorded and it will be shared in the YouTube. I think I have uploaded in YouTube. Okay, I'll share the link after the class. Right. I'm sharing the screen. Can you able to see the screen, please? Acknowledge me.
No, sir. No,
Can
sir.
you now?
Yes, sir.
Yes.
Yes, sir.
Yeah, I'm sharing my friend's notes, which I. Okay, it is for reference only. Yeah. Shall we wait for another 1 minute? Others to join, or can you continue?
Let's wait for a minute, sir. I said my friends to join.
Okay, ma, we'll wait for them. Around 22 participants are there now, so we'll wait for. Everyone, please rename with your number and name. Still few people: Meghna, Uttej Kumar, Srinivas, Josna, Tarak. You don't have mentioned. You didn't mention your number. Tejasvi, Jasmita. Please put your number first. 196, etc., etc. Then your name. I am telling from day one. Yeah. Student, what screen you are able to see now? Students,
Application of signal.
it's a PDF. Is it right? Is it a PDF? Someone respond. Is it a PDF? Classification of signals. It's the same.
Yes, sir.
Yes, sir. Yes, sir.
Right. Fantastic. Then I'll start the class as it is 11:03. 3 minutes already waited. Okay. So we discussed all those things. I one point I want to mention here. So I have opened this part. Okay. So I'm going slide down. Right. We discussed about classifications, analog and discrete distance analog signal. So usually these all are this type of signals are called continuous. This type of signals are called digital. You know, 1 and 0 are called digital. This continuous up and down, increasing, decreasing, such type of are called analog signals. Again, in analog signal, there are continuous and discrete two categories, and these are the example of discrete that also have shown. Even I have explained you even and odd. So even signals are called symmetric signals. Why even signal are called symmetric? Can anyone answer? Why even signals are called symmetric? Why? Because I told you this is my signal. So when I call it as a odd signal, sorry, when I call it as even, if I fold it like this, it will match with other half. It will match with other half. So symmetric type. Symmetry means replica like. Okay, this is the half. So this type of behavior. So that's the reason I'm calling this as this as symmetry. Other one is anti-symmetry. Okay, so to have explained, I've given some example, one problem also we discussed, or how to calculate even part, how to calculate odd part also we discussed, right, in the previous classes. Okay, now periodic and aperiodic we discussed, right, how to, yeah, what is a time period we discussed, this is a time period. So I'll annotate it just a second. So yeah, this is your, right, this is your, this one. Yeah, just a second. Yes. So yes, this is this one, only this part, right? This is your time period, t equal to pi by omega. So usually is a periodic signal, and this time period will be mentioned in this. We'll see few problems in the next classes. Okay, and then we have, just a minute, just a minute. I'm getting the important one. Yes, yes. I'm very, very sorry, students. There's an important call from the management, so I need to answer it. Very sorry. Yeah, I'm sorry. I think, yeah, I'm sharing the screen back. Please confirm me. Yeah. Can you able to see the screen now? Please, someone acknowledge me. I'm very sorry for the time wastage of
Yes,
2
sir.
minutes.
Yes,
Yeah,
sir. We
thank
can
you.
see,
Thank
sir.
you. Yeah, thank you so much. So we have discussed about this, all those things. The major point why I have came back to this is energy and power signals. We discussed little bit. Some energy will be there, some power will be there, etc., etc. But this formula I not yet given to you. This formula, right? I told you already. My signals and system is majorly depends on the mathematics. Into that, I'll only concentrate on two parameters in the mathematics. Only 2 points importantly in the mathematics. One is my favorite one, right? One is my favorite one, integration. Many people loves to do the integration, right? So this is one integration. The second one is irritating summation, right? So the first one is integration and the second one is summation. These two operations I'll use very, very, very much in this SS and signals and systems. So I will these two will cover 70% portion of our SS. I mean 70%, not completely max. Whatever max we are getting in the SS will be of 70% of these two operations. Right. So why? Because for continuous I'll use integration. For discrete I'll use summation. Right. You know what is a definition of integration? I don't know. Majorly I'll know some part which is related to our subject. That I'll explain you. Right. Try to understand what is integration. Right. So I have a some sort of area. This is a sort of area. Right. And this is a smaller area in that smaller area. So clearly I want to mention that. So this is second ECE classroom. This is second ECE classroom. Right. So I'm explaining about integration. Why? Because I want to use it here. So this is second ECE classroom. So among them, this is one part of this. So I have every detail of it. I have every detail of the smaller part. So if I extend it, if I integrate it, right? So if I integrate it, right, with the boundaries of this bigger one. So if I apply the boundaries of the bigger one, that boundaries are nothing but integration A to B. These are the boundaries, Nana. A to B. These are boundaries. This is the integration boundaries. If I apply this integration boundaries, I can get this whole blue color or purple, whatever you call, whole blue color, the total easy second year information I can get. I have only smaller. If I apply limits or integration, not limits, sorry, integration. If I apply integration, the whole class analysis or data I can get. That is advantage with this integration. Why summation? Why summation? Summation is similar, but it will be applied in this case. Right? It will be applied in this case. So this is again second year EC classroom. So these are the points on the second year classroom. Different points. There is no connection. Yeah. So this is a part. Right? These are the different points in that. This is the different points in that. Right. So now, is there any? Hello? Can you hear my screen?
Yes, sir.
What about annotation? Someone is trying to annotate. Please don't do that. So I'm losing my screen here. So this is my screen, and these are the various parts. So again, my God, what happened? And someone is trying to disturb me. Please be quiet. Okay. Okay, then I'll use another one. Right. So this shaded area is a second year classroom. The shaded portion is a second year classroom. So what I want to know is, I want to, all these are discrete. We see there is gaps between each and every word. Each and every word. So the total is a second year. In that one word is there, right? So there are some gap. There is no continuity in that. There is no continuity in that. So if I have one, if I apply limits, in the integration from a to r, if I apply limit from a to integer, so a is the starting one, integer ending one. If I put a limit summation a to integer, so then if I apply a common formula, I can get detail of complete paragraph. That is summation. Integration for continuous parts, summation for discrete parts. Keep in mind two concepts I'm mostly concentrating. Right now, so what is energy and power signal? Right, that we discussed already. So some signal, every signal may having some finite energy, right? Every signal having some finite energy and every signal having some power. I told those two are interlinked. We cannot separate them, right? So specifically, some signals are called energy signals. Some signals are called power signals. Why? When it is called energy signal or power signal, right? Before that, can we calculate energy of a signal? Yes, we can calculate energy of a signal, and this is the equation. This is a formula for energy calculation. What is the formula? E equals to limit t tends to infinity. Yeah, integral minus infinity to infinity mod x of t whole square. Right? Why I'm using mod x of t in this? Because energy. So, for example, if I give, right, uh if I give, for example, minus x square plus 4x minus 6. If I integrate it with respect to x, my answer, integration answer, after substituting t and t limits, so it may be a negative value. It may be a negative minus value. Can anyone say energy will be negative? Energy is a
No,
negative
sir.
quantity. No, energy should be a positive one. So that's the reason to overcome this negative part. So మనకి ఇక్కడ my intention is amount of energy. It might be a positive or negative. That you leave it side. But my intention is how much amount of energy is important. So for the amount, there is no amount is a magnitude. It is a quantity. For quantity, no need of signs or phases or symbols. So it's a quantity amount. So that's the reason I'm adding one modulus. Right? That is a formula, and especially this formula is only for, I told you integration means only for continuous signals. This is only for continuous signals. So for discrete, we have some other formula. Keep in mind, please. Okay. Now, the next, so same next formula. Discrete, you see, is there any difference in the formulas? Energy equals to limit n tends to infinity. There I'm using t tends to infinity, and here I'm using n tends to infinity. I'll tell you what is this n and t. Don't worry. So summation n equals to minus n to n, small n equal to minus n to n mod f x of n whole square. The same one. There I'm using integration. Here I'm using summation. Right, and there I'm using t, here I'm using n, because I told you in the first class itself, continuous signals usually represented with the time t, and discrete signals will be presented usually with n. Okay, discrete signals, small n, I'm writing it in the, yeah, continuous means cap t, small t, continuous means small t, discrete means n's. Right, discrete means n. Okay, here I'm using n, here I'm using t. Okay, so continuous means t, n means discrete. And one more. What is this t and t? What is a t and t? Right, so this t and t, and here n and n. These are nothing but time period. You know, periodic signal, right? So we'll calculate this energy and power are only for periodic signals, and this periodic signals having some time period. For example, right, this is some signal and this is a time period, for example. Right, this is a time signal having some time period from here to here. I'm drawing rough figure, don't misunderstand me. So this is a time period, some capital T, and this capital T is here. Okay, this is capital T is here. Okay, and this is again discrete, right? For discrete, I'm representing it n. Okay, there is no other issue in this. So this is a formula to calculate energy. Is a formula to calculate energy. See, this is a formula to calculate energy, and this is a formula to calculate energy for continuous and discrete signals. Yes. So two ways we have. Okay. Next. Right. So power signal, energy signal we have calculated. Right. Now this is energy. What is the formula for power? The same one for power. What is the change in formula for energy and power? What is the change? See this 1 by 2t is only the extra term compared with the previous one. Only 2t in this continuous, 1 by 2n plus 1 in the discrete. So remaining formulas are as it is, power and power, right? This is for continuous, this is for discrete. Second one for discrete, the first one for continuous. What's the difference between energy and power? Energy, there is no 1 by 2t. Here I added 1 by 2t. That is a difference, right? Now, right. So what is the energy signal? So for an energy signal, keep in mind this one, right? You always confuse. Right? Right. So the confusion is this one. Yeah. So you always confuse. That is this one. For energy signal, energy of any signal should be a what I call some value, not infinite, right? Some finite value. So if energy is finite, power is zero. It means, for example, right? So take a periodic signal. Yeah. F of t equals to sine 4 pi t. Yeah. This is a signal. F of t equal to sine 4 pi t. First of all, for this, how to calculate the periodicity? So compare this one with general equation. What is a general equation? Sine omega t. This is your general equation. So what is the omega here? Omega equals to 2 pi. Omega equals to 2 pi. This is my omega. So what is the omega usually? 2 pi by capital T. So otherwise omega equals to 2 pi f. F means frequency, 1 by T. So I think you have an idea. Right, I'm writing it here. Omega equals to 2 pi, right, 2 pi f. Omega equal to 2 pi f. F is a frequency of sine wave. Right. So this f can also be written as 2 pi by capital T. F means 1 by T. So I'm repeating, frequency is nothing but 1 by time period. These are the basics, very much important in your lifetime. You have to use all those things. F equal to 1 by 2 pi. You might be known all these things, right? So this is a time period. Reverse of time period is a frequency of any signal, right? So now can you tell me what is the time period of the sine 4 pi omega t? Sorry, so 4 pi t. So what is the time period? Capital T. Find out the capital T from this. Right. Find out the capital T from this. So what you have? So omega t equals to 2 pi. Omega t equals to 2 pi. Right. Sorry, omega equal to 2 pi. Omega means, sorry, yeah. Omega equal to 2 pi. That means omega 2 pi by capital T equals to 2 pi. Right. If I cancel this 2 pi and 2 pi, what is the leftover at capital T? Capital T equals to 1. So time period here is 1. So this is the time period, one cycle. I mean, 1 means 1 cycle. So this is T. Okay. So now keep this T in your mind. So what you have, right? So just a second, let me cancel the annotations. Yeah. Okay, so see this. Can I calculate the energy now? What is E? What is the formula, Nana? Right, what is the formula? E equals to limit t tends to infinity integral -1 to 1. Right, so -1 to 1 mod x of t whole square. What is the x of t? What is x of t? Sine. Here sine, right? X of t means f of t. Yeah, sine 4 pi t, sine 4 pi t here. So it will be sine square 4 pi t, sine square 4 pi t. So it can be written as 1 minus, right, 1 minus 2 sine 8 pi t. Correct or formula? Anything wrong? I'm converting that into with non-square because square of integration I can't do, right? So 1 minus 2 pi 2 sine by, sorry, I'm sorry, there is a mistake. Yeah, it is 1 minus sine 4 pi will become 8 pi now by 2. This is a conversion. This is a conversion. Yeah, this is a conversion in sine square into sine. Is it correct? Anyone knows? Yes or no? Is it correct or wrong, ma? Someone answer. Okay, right. So as per my knowledge, it is correct. How I did, you don't know maybe. So you know, right? Sine square theta equals to, right? Sorry, cos square 2 theta equal cos 2 theta equal to sine square theta minus cos square theta. One formula. With that, I can do this. Right. Someone please answer. Are you getting my class or not?
Sir.
Suresh, are you able to understand my class?
Yes, sir. Yes, sir.
Right, then, yeah. So this is conversion is sine into cos. There may be a mistake here. I don't remember exactly, but it is almost correct. So for cos, I'll get plus here. I'll get a plus here. For cos, I'll get a plus here. For sine, it is correct. Right. So now I can integrate it. What I'll get if I integrate it? So there is a limit. I'm not writing. Keep it aside. So 1 by 2. Right. This 1 by 2 also I'm keeping outside. And limit also there. I'm not writing. Please try to understand. So what is one integration? It is t. One integration is t minus sine 8 pi integration. Sine 8 pi integration. Sine 8 pi integration. Someone answer. Cos. Sai Suresh, what is the sine 8 pi integration?
Cos
8
pi by
by 8.
Cos 8 pi by 8. Right.
8.
Any minus?
No, sir.
Cos derivative is minus sine. Minus వస్తుంది అనుకుంటాను. No. Right. Yeah. So, and the limits are minus 1 to 1. So, this is 1 by 2. Yeah. So, see, if I put 1 here, 1 here, t means 1. I'm applying the limits of integrations now. It is 1 minus cos 8 pi. So, 8 pi t. I'm sorry, there is a t here. Yeah. So, if I put 1 here, cos 8 pi into 1. So, cos 8 pi, cos 8 pi, cos 2 pi, cos 0, all are 1. I think, right? So, it is 1 by 8. Okay, so now applying lower limit, so it will become minus 1, and this minus and minus will become plus. This minus and minus will become plus. So this is 1 by 8. So, okay, is it right or wrong? Any doubt in this? Right. So this is nicely cancels minus 1 and 1, minus 1 by 8 by plus 1 by 8. So finally, your energy, what I'm calculating is how much? 0. Right. So like that, I'm calculating energy. What is the energy I've calculated? So what is the energy of my previous waveform which I have taken? So for my previous waveform which I have taken, for that my energy is 0. Right. A signal, is it a finite value or infinite value?
Finite.
It's a finite but 0. It's a finite but 0. Right, keep in mind. So see this definition. So 0 less than E less than infinity, and need to calculate power. Power is 0. Then I can say my sine 4 pi t is A. If my sine 4 pi t energy is not 0, and if I got power as 0, right, what is the procedure for power? I've given a formula in the below. So if I calculate both, if it is satisfy both the condition, then my sine 4 pi t is an energy signal. But here I got energy is 0, means the first condition is not satisfying, right? But second one we don't want because first itself failed. Second one not bothered. So if at least one is failed, it's not an energy signal. So can you please conclude me, is it energy signal or not? Sine 4 pi t. Energy or not?
No, sir.
No, because energy of the signal is 0. So it's not a energy signal. Right. So
Sir.
this is the, yeah. Yes, Nana.
సార్ అది సైన్ స్క్వేర్ ది 1 మైనస్ కాస్ 2 తెలియదు కదా సార్.
That's what I'm asking. Right. Fine. No issue, no problem. So if it is 1 minus cos theta, no problem. But my intention is your answer is not 0. Right. Your answer is not 0. And power, you have calculated power here. You have calculated power here. So this is the formula for power. Right. This is the formula for power. This part. The above one. So this part. So this is the formula for power. So power is the 0. That value should be 0. And energy is not 0. This one. Energy is not 0. Then my signal is called energy signal. One condition. And what is the definition for power? So this is for energy signal. What is the definition for power signal? Power should be finite. Energy is infinity. So second condition, if any signal having right infinite power, infinite energy, then it is called power signal. So I'll give you some homeworks in the class today, right after the class or in the WhatsApp message also. I'll give you some homeworks. Keep in mind, you need to use these formulas and need to calculate the right energy or power signals for the given problems. So keep in mind, right? Keep in mind. So you have to note down what is I'm explaining. So you need to maintain a running notes, right? I hope you are maintaining. You are not a kids to tell, right? So same, take a sine, cos, sine, signal, sine. Now we'll take cos. Why to take sine? So now you take a cos. 2t. Now I'm not taking cos t. Right. So cos 2t, I'm taking cos 2t. And what is omega equals to 2? Omega equals to 2. That means 2 pi by t. 2 pi by t equals to 2. 2 to cancel beautifully. My t time period is equals to pi. Time period is equals to pi. So I got some time period pi in this case. Okay, so now, right, for this cos 2t, put in the equation. What is the formula for, right, power? Now we'll go for the power, not for the, right, yeah, we'll go for the power, so not for the this. So what is the formula for power? So here also, right, 1 by, what is 2t, what is 1 by 2 pi. Why pi ma? Why pi? Because t is pi, earlier I have calculated, and it is minus pi to pi. This is time period. And x of t, that is cos square 2t. Cos square 2t, as Sai Suresh said, we can convert it as 1 plus
కాస్ 2x by 2.
cos 4t. Right, 2t
4t by 2.
4t by 2. So if I integrate it, I'm doing it on the top, don't confuse. It is 1 by 2 pi, right? 1 by 2 pi, right? Into this 2 will become 4, Nana. So this will become 1 by 4 pi, and this will become, one integration is t, right? Plus, right? Sorry, yeah. Integration of cos. What is integration of cos? What is integration of cos? Minus sine 40 by 4. Right? Now put t minus pi to pi. These are the limits. Right? What I'll get? 1 by 4 pi into, yeah. So upper limit pi, in place of t, if I put a upper limit pi, lower limit minus pi, so this t will be 0. So I'm directly writing అర్థమవుతుందా? So upper
Yes, sir.
limit pi t place లో if I put upper limit pi in place of t, it is pi. Lower limit minus pi. So these two will be cancelled. Sorry, not correct. It's wrong. Yeah, we are mistaken. So it is pi. Upper limit is pi minus sine
Minus
4 pi. Sine 4 pi value how much? Sine 4 pi will be 0. Yes, sine 4 pi, sine 2 pi, sine 6 pi, all
Yes, sir.
sine 2n pi, all sine 2n pi values, all sine 2n pi values are 0. Okay, so 0 by 4 is 0. Now lower limit minus of minus t, now it is become plus t. Minus of, it is lower limit, right? I will get minus, again it is minus pi. So it is become plus pi, don't confuse. I hope you understood this. So it is lower limit, right? You'll get obviously a minus, and that minus in this lower limit minus pi will become plus pi. So pi plus pi 2 pi. So it is totally 2 pi by 4 pi. 2 pi by 4 pi. So what is the answer? 1 by 2. Okay. So is there any t terms again to apply the limits? Is there any t times to apply the limit? This one. T tends to infinity. Is there anything there? No. So no need of bothering about limitations. So this is about my power. Now tell me, is it a finite quantity or infinite? It is between this 1 by 2 is in between 1 by 2 is in between 0 and infinity. So I am calculated my power is 1 by 2. Now, the same manner you calculate the energy. How can you calculate the energy? I have explained the previous problem, right? So calculate the energy in the same cos 2t, and if you get, so my power is finite here. So if you get your energy is infinite, and already power is 1 by 2, then my Hana, please, Kashyap. Yeah. So then my cos 2t. Then my cos 2t is a power signal. This is a power signal. So this is a beauty in this concept. What's a beauty? So what is the energy signal we have learned? What is a formula? How to calculate? All those things we discussed in this concept. Any doubt till now in this class? Please respond. I'm moving to the next topic. So I'll give you some problems today. So you please take it as homework and post me in my WhatsApp personally, not in the class. Okay, a small homework of few problems only based on integration. Okay, so these are the small homework for your more understanding the concept, right? So deterministic random we studied. These are the first picture is a random deterministic, second picture is a random. Causal, non-causal we studied. So now this part is over. The next part I am moving to the step signal and what is a mathematical representation of a step signal. So this is a mathematical way to represent. What is a mathematical step? So usually I represent step with u of t. And sometimes we'll call step as a unit step. What is the difference between step and unit step? Right. What is the difference between step and unit step? So unit step means, look at the height of this line. What is the height of this line? So this is height. So this is the height, right? So what is the height of this line? It is 1. So if this is called height, or told to sometimes again, I can also call it as amplitude. I can also call it as magnitude, right? So the magnitude or amplitude of this signal, if it is 1, right? If any signal, not this one, any signal, amplitude is 1. Usually that will call that as a unit. And this one is a step signal. So this is a unit step. Unit step. U of t. And what is u of t? Look at this. It is 1. U of t is 1. Right? Yeah. U of t is 1 for t greater than or equal to 0. Means this is 0. From t greater than or equal to 0, it is 1. And 0 for t less than 0. Is there any signal for t less than 0? No. There is no signal. So for t less than 0, there is no signal. So we call, right, this part, right side part, right? So this type of signals usually will call as step signal. Step signal. And the most important, this we already discussed. I asked you to example, and some student, I don't know, maybe I think Sai Suresh, I hope. So he answered dead body is an example of unit step. Okay, so I told this is not correct answer, and I said, right, for lifelong from 0 to infinity it should not be constant. For some certain, from certain level, from here to here I can say it is constant. From here to here I can say it is constant. This is step. Just a minute. From here to here. 1 second. Anna. Don't touch anything. Mind your listening. Don't touch anything. Okay? Teacher will allow you. Yeah. Wait. Okay? That's the thing. Okay, na? Be here. Yeah. Akade only two. Yeah, sorry. So for certain interval from here to here, for some time, it may be a 1 day or 1 hour or 1 second or 10 minutes or 1 year, right? That depends on application. We can take the time bound, but certain time, until that time, I can say it is constant. This is a step, right? So any example, if you want to observe at this, right? Are you using stabilizers in your home? Stabilizers. Anyone please answer who are using stabilizers in your home?
Yes, sir. Yes, sir.
Right. I think Sai Suresh again answered me. What is the purpose of a stabilizer?
It will manage the high voltage to.
Right. So it will close. Meeting will close in 5 minutes. No issue. Someone please take the screenshots, ma. Right.
I took,
So
sir.
yeah, fine. Thank you, Nana. Later you share me. So stabilizer యొక్క main advantage, stabilizer's main advantage or main work is it will produce constant stabilized means constant output to the device. That may be a refrigerator or TV or washing machine or the air cooler or air conditioner, whatever. Stabilizer will take the fluctuation in input. What are the fluctuations we have input, and that will be stabilized. And applied to the TV or refrigerator. And one more, right? So normally you can see two types of currents. One is AC current, second one is DC current. Yes, excellent. So AC means alternative current, DC means direct current, and whatever laptop or TV we are using all are DC current, and DC current means those currents will be like this only, means this step only. But this voltage may not be one, it may be 12 volt DC, or for mobile phone 3.4 volts, 3.7 volts DC, or for TV 12 volts DC. Like that, from appliance to appliance there may be a variation. But whatever power supplies we are using, all are DC voltages. These all are example of step. I hope you understood. Right. So tomorrow, this is the expression. Tomorrow we'll discuss about, right, other signals, and this is a example of your step. This is this is the equation of step. Tomorrow we'll see the, right. Tomorrow we'll see about this. What is the other signals? We'll see in the next class. See you in the next class. The time is about to end. Thank you. The time is about to end. Maybe 1 minute we have. Right. Meanwhile, please take your screenshot. Please, while you're coming to the next class, take the rename yourself. Right? Please, everybody, please rename yourself with number and name. Thank you. We'll see you in the next class.